Hey everybody, thank you for sticking around till the final countdown here. Apologize for having to put somebody at the end of the agenda, but
we're all bitter enders together. Thank you.
I won't have to give them the 5-minute warning because everyone will just leave for the evening reception. But thank you, Ben and David are going to walk through some interesting stuff for you, and I think there's some goodies you're going to get at the end here too. And if you have any questions, you can save them to the end or mix them in however you want. We've got till 6 o'clock, so take it away, guys. Thanks.
All right, thank you. Thank you so much. So I'm David Potes, and I'm with Amazon Web Services, and joined here by Ben Lackey, Couchbase, and he does all the cloud stuff with, apparently there's other clouds too, but we love having him, work with us on AWS, and I'm part of the Partner Solutions Architecture team at AWS. So essentially, what we do is we work with partners to help them integrate their software with AWS and to be able to do kind of cool stuff. So we've actually done a lot of work together on Couchbase, and I can tell you, if you want the TLDR version, it runs great on AWS. But before we get to that, do you want to talk about the partnership at all, Ben?
Yeah, sure.
Okay, go ahead.
So I've got 2 quick slides just kind of giving an overview of where we are with AWS. After that, David's going to go into different components of AWS, compute, storage, and network in detail. After that, I'll discuss best practices for running Couchbase on AWS a bit, followed by a quick overview of some deployment options and a little demo. So Couchbase and AWS, over a quarter of our customers are running on AWS today. We've been on the marketplace since 2012, which was pretty early. Number of white papers, different artifacts through all that. Earlier this year, Couchbase became an AWS Advanced Partner. And we've been putting a ton of effort into joint engineering together. So these are things like CloudFormation templates, tight integrations with a new multi-AMI offering in the marketplace I'll mention, work with auto-scaling groups, and other things like that.
Ding!
Tons of customers using Couchbase on AWS. These are 4 examples. Each has a landing page and a case study on our website that goes into the use case in more detail. But a lot of our work is just to make Couchbase on AWS a first-class, really easy-to-use customer experience.
Cool. Thanks for that, Ben. What I'm planning to talk about today is something that I call kind of the Holy Trinity, and we're going to talk about storage, compute, and networking, right? Without which it's difficult to run any kind of application. So stay with me. I do want to talk first about storage. So when we think about storage on AWS and notionally kind of anywhere, it kind of falls into 3 different categories. So I'm going to start with block storage, and we have a product around this called Amazon EBS. It's Elastic Block Storage, and it looks a lot like what you may have experienced. I spent a lot of time in the data center. We had storage area networks, and we could mount up like block storage. And the way to think about it is it is a service, right? So when we think about block storage being mounted, it's not necessarily that we're physically grafting a disk onto your instance, right? This is cloud, this is virtual. So think of it as block storage as a service. And when we actually do it as a service, we have some cool opportunities in terms of delivering features to customers around things like snapshots or being able to provision exactly how many IOPS that you want and being able to use all these things, which I'll go into in a little bit. So if we kind of take the next step up, now we're looking at file system semantics. And surely most of the folks here have dealt with a file system at least once or twice or thrice or 50,000 times. And we have a product positioned there as well, Amazon EFS. It's our elastic file storage. And really what that does is it gives you an NFS or an SMB interface to be able to connect to this file system. No servers to manage behind it. It's presented as a file system that you can connect to with either mount points or SMB connections. And kind of the next step up, and hopefully many of you have heard of Amazon S3. It's a fun fact. Some people think that it's our oldest service. It's actually the second oldest service. And the oldest service was actually SQS, which is the simple queuing service. Buy me a beer sometime and I can tell you stories about why that was first. But S3, now we've moved up into the region where it's actually object storage. So we treat these objects and we get some cool features with this too, right? So we get just absolutely massive scalability. If you've ever watched a Netflix movie, or if you've ever done anything on sites like Zynga, or there's a long list of customers that are doing really cool things with S3. But what I like about it most is that it's incredibly durable. So it's designed for 11 nines of durability, which if you actually do the math and get your calculator out, that's an insane number. So somewhere around, you may lose one item every million years or so, which is pretty good, right? So we'll take it. And it exposes a number of REST APIs and native APIs and SDKs that you can actually use to build into applications, and a ton of cool features around that. And we'll dive into these in a little bit, but first I want to go back in a little bit of history, right? So I mentioned, the 2006, Pluto was a planet. Saddam Hussein was in charge somewhere. It was a long time ago, okay? And that's when we actually launched kind of the first instance storage. And then 2008, there was a different president. He seemed pretty cool. And thanks, I appreciate the laughs. And that's when we launched EBS. And EBS actually launched on magnetic storage because that was essentially state of the art at the time. And as we kind of move through time, we can see that SSDs came out, data volume encryption, and then boot volume encryption, which was a very cool feature. The streaming optimized drives, and then this year, elastic volumes. So you can now actually resize EBS volumes while they're attached to something. You don't have to do kind of a build and copy and all that back end. It starts to look like something that you can actually use while you're growing. So when we think about the block storage offerings, the first one that I would want to talk about is the EC2 Instance Store. Sometimes this is called ephemeral storage. And it was really kind of the first thing that came out. So this was 2006 again. And Pluto's back where it's supposed to be. And Instance Store is a lot like what you might have seen as direct attached storage in the data center, right? These are they're actual physical disks, and they're local to your instances, which is cool because you can get kind of blazing fast throughput to them. But there's some challenges around that too. And there's a reason why we call it ephemeral, right? So if you stop that instance, that storage goes away, right? So kind of a big roadblock, but there are a few misconceptions around that. For one, this storage actually will survive a reboot. So ephemeral storage, you reboot your system, it's still there. Trust me, it's still there. If you're going to run an application on that ephemeral storage, though, instances die and it can go away, right? As Werner, our CTO, says, everything fails all the time. I swear he's actually an optimist, but he's right about this. We should always plan for failure. So if we're using ephemeral storage, we want to make sure that we're using some sort of application level replication that can help us survive that. So kind of stepping into the next thing is now we have EBS, and it's backed with SSDs, right? Which give us kind of great general purpose performance. SSDs do pretty good on sequential reads and writes. They do great on random reads and writes. And the two types we have here are GP2 and IO1. And many of you may know IO1 is actually provisioned IOPS. And if you wanted to walk away with one thing that you learned from this presentation, GP2 is a jack of all trades. It's very difficult to go wrong using that. So if you don't want to kind of get into the details of your storage needs or your IO profiling, you can use GP2 and call it a day. The third category, and these are relatively new, so I think we came out with these late last year. I call it the return of magnetic drives, right? Because these are actually HDD-backed volumes, And what we can do is we can actually give you volumes that are in the area of 30 to 40% cheaper than GP2. What these drives are designed for is throughput. And we'll talk about that in a minute. But throughput is really the actual volume of data that you can drive to these drives, that you can push to these drives. And the ST1 is kind of the slightly faster one for warmer data. SC1 is for slightly colder data. I always think of SC as cold, right, or super cold. So that kind of helps us understand that. And you can see here, and my formatting is kind of wacky. So GP2, general purpose, right? IO1 is provisioned IOPS, and something to remember about provisioned IOPS is not only am I provisioning a certain number of IOPS, but if you actually, and you can go dig this up on YouTube, the performance profile of provisioned IOPS is much narrower too. So you're actually getting a very, very predictable performance in the order of less than a millisecond difference in response time over many millions of reads. So very tight box, whereas GP2 is going to be a little bit wider. ST1 and SC1, those are your throughput optimized. So if you're doing big block sequential I/O, you can save some money, and those really crank in that. But how do I decide, right? Well, first of all, we're going to do a little math, and I promise to keep it fairly light. When we think about how much I/O we want to drive, there's just a couple of measures that we need to be aware of. So first of all, you have IOPS, right? Along with IOPS, we need to know what the I/O size is, and IOPS times I/O size is going to give us actual throughput. And typically, we're going to measure this in megabytes per second, although you may hear something called MB-bytes, which is just a base 10 version of that. So I actually have this chooser here, right? So first of all, when you're thinking about your I/O characteristics, what's more important? Is it IOPS or is it throughput? And if you're unsure, where's your bottleneck, right? Are you running out of IOPS, or are you trying to 10 pounds of something or other in a 5-pound bag? Once you've kind of decided whether you need throughput or IOPS, and we'll look at the examples, say that I need more than 65,000 IOPS, and this might be a gigantic cluster that I'm driving storage to. And the next question to ask yourself is, what are my latency needs? And do I need latency in the order of hundreds of microseconds, or do I need single-digit millisecond latency? And if you find that you need more than 65,000 IOPS, you need that less than millisecond latency, that's when you actually do want to look at the ephemeral storage. And I have the I2, I3 here as an example of that. So that's the high I/O boxes. You can actually get an insane amount of I/O down to these boxes into the storage. But not everybody needs that. And like I said, there's a few more engineering challenges around application replication, and there's a little more work. If you need less than or equal to 10,000 IOPS, again, be a hero and say, GP2 is just fine for me. Whereas, if you need a little more, then we can do the provisioned IOPS. Now, on the throughput side, if you're using large sequential I/O and you need kind of very large aggregate throughput, now we have an instance model there that's the D2. And actually go into instances in a little bit. And we'll post these slides, right? Yeah, so if you want to be able to use this, you can. So that's step one, right? We understand the storage. Let's talk a little bit about compute. And for those of you that are familiar with kind of virtualization concepts, there's really not a lot new under the sun here, right? You know that at some point there's a physical box and a physical room, and that's going to have a hypervisor on it. And then on top of the hypervisor, you have various guests, right? Pretty straightforward stuff that we've been doing for quite some time. I seem fixated on 2006 for a reason. That's when a lot of this stuff launched. In the beginning, there was one instance. It was the M1. M stood for medium. One size fit all because there was only one size, right? It's a pretty straightforward, makes it super simple. But a lot of these instance types have proliferated, and I get a lot of questions about it. But one of the ways that you can really understand that is that there's a family, a generation, and then a sizing. And the kind of the various elements of this will tell you exactly what this does. So in this case, the C stands for compute optimized. The C4s are kind of state-of-the-art from the last year or so. And then an extra large is going to have a certain number of virtual CPUs that we can utilize. So there's a lot of families now, and I'll give you another shortcut. I'm a big fan of TLDR for everybody. So a good shortcut to think of is that M4 is good for just about anything, but great at very little, right? Because it's not really tuned to different sorts of use cases. So if you don't want to think about it, if you're a set it and forget it kind of person, start with the M4, see if you run into kind of CPU issues. Now, on the other end of the spectrum, we have some memory optimized boxes, and definitely go look at the numbers of the X1s. They're insane. Okay, so they have like ridiculous amounts of memory, but for most people's use cases, the R4 is actually a much better fit. So you're getting dense memory on the instance, and really it plays to what is the ratio of CPU to memory on the box. And then we've got a few different ones. So we have the compute optimized that I pointed out in the last slide. Very high-end processors and lots of cool things around instruction sets. And if you're a Linux wizard, there's P states and C states, and a lot of like little tweaks that you can do if you're kind of a knobs and dials person. Interesting, but probably not germane to most use cases, are the accelerated ones. So we have P2s, we have the F1s that are flip chips, G2s, which are graphically optimized, and then the D2s and the I3s that I talked about just previously. So generally with Couchbase, and Ben and I talked this over, most of the time you're either going to go with an M4 or an R4, depending on how much memory you need on that instance. So we've talked about 2 of 3. The third of the Holy Trinity is really about networking, and trust me, like I'm not a huge fan of networking, as kind of like the everything, but it's important to understand a few of these things so that all of us as potential cloud administrators or CTOs know enough to be less dangerous. So the first notion that I want to give you is network ACLs. So these, I call them NACLs for short because I like abbreviations. These are really just stateless firewalls, right? So I can set up rules saying, inbound rule, allow everything, deny everything. Outbound rule, allow everything, deny everything. So we can apply those on a subnet basis, so we can decide which subnets we want to give those NACLs to. And I can translate it into English, allow all traffic in, right? So probably not a great idea for anything sensitive, but as we're getting started, we'll use that as a notion. So security groups are really, this is kind of the other way that we can control traffic. And when we design our security groups, we really want to try to follow the application structure. So in this sense, I have a bunch of web servers, and I'm going to say allow all traffic on port 80, right? The world needs to see our web servers. I'm going to allow traffic. But I don't want them to get to the back end. So I'm going to use a security group that says only the web servers can talk to the back end on whatever ports that we're using here. So in this case, translating to English, right? Anybody can go to port 80 via the security group. Whereas, I've got 2345, and bonus points for anybody who knows what that port is, that only my instances, and you'll see that the source is SG and then an identifier. Only the instances in my web server security group can reach instances in the security group. So a couple of additional notes, asking a security person, or some of you probably are security people, least privilege, right? Don't give applications or frankly humans more access than they need to be dangerous. And note that VPCs, like I showed you an inbound rule, we actually set outbound rules too. So we can close the door on things going on out on port 666 or other kind of dangerous activity. We can block that before it starts. And I think the biggest one that I would look at here is a lot of application structures really lend themselves well to a very simplified security scheme. So I have security groups, who can reach me, and IAM roles of what I can do. So a great example, say that I'm storing, static content for my website on S3, right? I'm going to have a security group that says, you can get in to port 80, but also those web servers are going to have something that they can do, and they can read S3 to be able to serve up that content. And this would follow the structure of my application. So I'm going to hand off to Ben. Hopefully I've talked as fast as I normally do and filled you full of information. But I do want to hand off to Ben. Ben's got some really cool specific stuff for doing Couchbase. So take it away, my friend.
Cool, thanks. Right, so I'm going to kind of take everything David just took you through and sort of represent it, but in a Couchbase specific context. And I'm going to start off with two big, complicated architecture pictures. This one is kind of, it's a possible deployment. And we have two clusters running. One of them's running in US East. One of them's running in AP South, which I think is Mumbai, if I'm remembering properly. And I picked that one because it's unusual in that it only has two availability zones. One of our recommendations is spread the nodes you're deploying out across all the available availability zones, and then configure your server groups within Couchbase appropriately. So US East, in this case, has more AZs than 3, but we only have 3 nodes, so we're spread out across 3 AZs. Those 3 nodes are within an auto-scaling group, and they can be scaled up or down. Presumably in this picture, they're running all the different Couchbase services. So data, index, query, maybe full-text search, which some of you presumably learned about over the last day. Then we have that XDCR link all the way across the world over to those 2 AZs. And in that case, we have 4 nodes running. So we get the nodes clustered together a little more with 2 nodes per AZ. Once again, the auto-scaling group spanning the whole region, and you're able to scale up and down within that. That's one example. Bringing it up to a slightly higher level, rather than thinking about those individual nodes, if we just think about groups of instances. So here's an example showing how things might look like if you're using MDS, our multi-dimensional scaling. So in the previous example, we had all the services running on every node. In this example, we have in US East 1, an auto-scaling group that's running just data, another that's running index and query, and another that's running search. And these auto-scaling groups can be scaled up or down accordingly. We can also use different instances for those different services. Data as an example, we might want to go really heavy on disk, whereas index and query, we might want to go more heavy on compute and memory. In a similar way, we have that same XDCR link, and that's down once again to AP South, and we're running all the services on one node there. In this scenario, maybe US East sees a lot more traffic, and we have some small regional office down in AP South, and that's why the deployment's smaller. None of this is meant to be prescriptive. It's just examples of how you might put these concepts together. So now I'm going to drill down into them a little bit. So compute. Kind of our recommendations for what to do there. For the vast majority of use cases, you probably want to use EBS-backed instances. David mentioned the M4 is kind of the all-around go-to. The T2s can be interesting for very, very small workloads as well. And then the C4s and R4s tend to be useful for more demanding workloads. If you're not overly opinionated about what you're doing, kind of the big easy button, R4.4XL, it's just a great node type to go to. 16 cores, 100 some odd gig of RAM. Similarly, we recommend putting things in auto-scaling groups. It eases manageability, but typically you want to disable auto-scaling and then scale manually depending on how your load shifts or your demand changes. Right, storage, very similar thing. So David talked a bit about the different kinds of EBS. GP2 is the all-around, just easy go-to. It's SSD backed, it supports encryption, it's really, really manageable. So say you deploy a cluster and each node has 100 gig per node and you decide you need to scale up the size on those nodes, really easy to move from 100 gig up to a terabyte. Much harder if you're depending on the instance stores. IO1, more performant, more expensive, just a standard you get what you pay for kind of thing. The instance stores, they just introduce a lot more variables. We tend to see customers with very demanding use cases using those. You lose some things in manageability, which you make back in performance. The templates we have that set up clusters separate out the OS and the data drives. And it's an ongoing debate what the best way to do that is. We're currently recommending separating them out with the thought that if you fill up your data drive, it's not going to bring down your node without a disk issues. The other side of that argument is if you put OS and data on the same spot and you're under the throughput limits that Amazon has, you'll get marginally more performance from that extra 8 gig that the OS drive takes up. So, balance. Last thing, networking. So really strongly recommend using the default VPC. It's so much easier. The subnets are all created. You can create an auto-scaling group just targeting a region, and it will automatically spread the nodes out over the available AZs. You don't need to think about anything. If you are a more advanced user and creating your own VPC, Amazon has a Quick Start VPC that'll help you with that. Regardless, use the VPC model. Don't use the old classic network model. Missing a lot of features if you do that. We recommend configuring the nodes to use the public DNS. The public DNS in Amazon is a split horizon DNS. And that means when the node is accessed from outside the VPC, the public DNS will resolve to the public IP address. And that enables things like using XDCR. It's also great for developer experience. If you're developing an application and want to connect up to the node from your laptop, that'll actually work. If the nodes are trying to talk within the VPC, that public DNS will resolve to the private IP address, so that all that will stay within Amazon for those connections. Configure security groups to allow XDCR access, remote client access, and then back to the principle of least privilege, deny everything else. Yeah, so there's your crash course in best practices for Amazon. I'm going to move on to some deployment options, but please come by later, ask questions, talk about this stuff, and I'm always available to discuss it in more detail. So all these best practices, we've been working very closely with Amazon to try to codify in infrastructure as code. And Amazon's technology for infrastructure as code is called CloudFormation. It's these JSON-based deployment templates. Ours are available a number of different ways. One way they're available is through the AWS Marketplace. So we have two products. We have Server and Sync Gateway at its core. On the AWS Marketplace, we have AMIs, Amazon Machine Images, effectively VM images, built with those products on the latest versions of Amazon Linux. If you want, you can actually purchase that in a utility model, hourly pricing on demand model, or if you're an existing Couchbase customer, you can bring your own license. And then we have those AMIs. We also have the CloudFormation templates that kind of nest those AMIs together and deploy a whole cluster with a click-through experience, largely conforming to those best practices I just went through. One other thing I'm really excited about is in the last few weeks, we've been working with Amazon on this multi-AMI offer. And this allows you to, with a single CloudFormation template, through that marketplace wizard, launch both Server and Sync Gateway all configured in one deployment that works together. And you can kind of chain these together too. So you can deploy once in, say, US East, and deploy again in US West, and then point the XDCR links at each other, and you have geographical replication.
Boom, right?
Yeah, no, it's good. Kind of the final way to deploy for more advanced users, I mean, all this stuff is open source. It's up on GitHub, and you can go see the marketplace templates. I wouldn't typically recommend using the marketplace templates themselves, as they have some things that are unique to marketplace. In that same repo, we have a kind of stripped down simplified template that's very readable and is a good place to start customizing and changing things to meet your needs. So what we typically see customers doing is kind of starting out a marketplace, hitting the bounds of what that provides, and then transitioning over to GitHub, potentially forking the repo. And I mean, these things are templates. Customize them to do what you need to do. So that ends it for slide time. I'm going to switch over to a little demo. All right. And what I have here is a web browser open to this Amazon blog I'm really excited about. So this is the multi-AMI thing. And somewhere in here, yeah, there's Couchbase. Vendors such as Couchbase are doing this. So if I click here, it's going to redirect me over to the marketplace, and I can go through and deploy a cluster. And this is going to take us just a couple minutes. So you just sort of next. Pick a deployment option. That can be hourly or BYOL. I'm going to say hourly. Pick a version of the product you want to launch. We're supporting 4.6 because a lot of customers are still on there, but if you're at this conference, you're probably excited about all the stuff in 5. I could pick a region. I'm going to say East and continue to launch. And next, I need to choose the launch action. There's really only one, CloudFormation, since I'm launching a deployment that includes both server and sync gateway all together. And I hit launch. It's now pre-populated this with the location of the template. So all I need to do is hit next. And then I have a couple things I can choose. So, I need to pick a name for the stack. Stack in Amazon is basically a deployment. It's a grouping of different resources together. I need to pick a key. I have a pre-existing key I've used for other deployments. And then I need to pick a password. And this password is going to be the password I use to log into Couchbase, the web UI. And it's going to pre-configure the cluster to do all that for us. Server disk size is the size of the EBS volumes that are attached to each node. Those are GP2. If you wanted to use a different kind of storage, fork the template, modify it to use the kind of storage you want. I'm going to deploy 4 servers. And this SSH CIDR is who I allow to SSH into the nodes. And all zeros like this means I'm going to allow anyone to SSH in. A lot of this just depends on how you work. I work from airplanes and things a lot, so locking down to specific IP addresses is really a no-go. If you always work out of the same location, maybe you can lock it down. 2 sync gateways, and I need a username to log into the cluster. Don't really need to remember that. If I wanted to tag the deployment at all, I could do that right here. And I see this kind of summary. I acknowledge that this could create IAM stuff, and it does. And now it's running. And if I hit refresh here, I should see it. Couchbase, create in progress. I can click on it, see what it's doing. It's made a security group so far and some other things. This, in my experience, takes roughly 6 minutes to run, but we have 6 minutes left in this whole talk, and I'd love to have some questions. So I cheated. I made one beforehand. And you can see this is what it looks like if the whole thing runs through. So if I go over here and go to EC2 here, I can see I have 6 running instances and 10 volumes. So let me explain what's going on there. So I have 4 instances running server. I have 2 instances running sync gateway. The 4 server instances have 2 disks each, 1 OS disk, 1 data disk. The sync gateway nodes don't have a data disk, they just have OS. So we have 8 plus 2 equals 10 volumes. Click on there, and we can see our instances here. I see these different servers. I see sync gateway. One of these says server rally, and when the cluster comes up, it picks an arbitrary node in the auto-scaling group for everyone to connect to and rally against and build up the cluster. There's nothing special about this node, and after the initial deployment, there's nothing different about that node at all. We're just tagging that there because it might be interesting in debugging and looking at the deployment, depending on what you do. But if I go here, I can grab this guy's public IP address, and let me paste it in here, put 8091, and there's Couchbase, and I'm gonna log in with the username and password I specified earlier. Don't really need to save that. And sure enough, I have a cluster running with 4 nodes there. And I can do the same thing back here if I grab one of my sync gateway nodes. And I'm gonna grab its IP. And if I go to 4985 and admin like this, I can see the sync gateway admin. So that's boom, boom, next, Couchbase cluster up and running in, well, let's say less than 10 minutes. So happy to take some questions, and then we have a little present for you if you would like to try this yourselves. You can send an email to partners@couchbase.com. We have a little reminder card with a link, and you can get a $100 credit on Amazon to apply to your account to deploy this.
Yeah, so the idea is, if you want to give it a try, we're willing to indemnify you of that with $100 credit. Even if you're working in your employer's account or enterprise account, you can still apply these credits to that account. So think of it as a no-risk offer. So I'm going to circle through and pass these out to anybody that's interested. Ben, I think you got a couple of minutes for questions.
Yeah.
He's got a question for Ben.
Yeah, if you have any questions, I'll bring the mic to you.
Hi, on your multi-dimensional scaling slide, you
Yeah.
showed, data service in one availability zone, and index service in another availability zone. And what would happen if one of the availability zones became unavailable? What are the trade-offs between putting all the instances of a service in an availability zone as opposed to making all services available across each of the availability zones?
Maybe I need to work on my diagram a bit. If you look very closely, you see up there US East, that's a region. And then within that region, I have 3 auto-scaling groups. And those auto-scaling groups are actually meant to be spanning all the AZs within US East in this case. So we would distribute across all the AZs and not fail in a single availability zone.
Okay.
Good?
Good.
Good question.
Yeah, and I need to make my diagram clearer.
That's why
clearly.
it's multi-dimensional scaling, which means it's hard to put in a 2-dimensional diagram. Any other question? And if you like getting freebies and you like having these kinds of talks here, use the code. Use the code. Show them there's all this demand from Couchbase Connect attendees.
Please.
So one of the recommended configurations that I've heard come out of some of the architecture consulting we've had is to use a load balancer on port 8091 just for the bootstrap process. Does the CloudFormation template have an option to create one of those?
A load balancer in front of 8091.
Yeah, what it does, it initially bootstraps through it, and then after that, it direct connects to the nodes, but that way it gives you a single point to configure all your clients to connect to instead of multiple points.
I see. Okay, so it's an alternative way to solve the rally problem.
Yes.
And that's a clever solution to the rally problem. So yeah, you create, I have seen this before, you create an elastic IP, you attach it to whatever, or a load balancer, and then everything rallies off that. Yeah, you can totally do that. We're trying to solve it in a slightly lighter weight approach, and that's the advantage of this. Because after you've built the cluster, you don't really need that ELB anymore.
Well, it's still helpful for your actual clients because instead of needing to configure every node in my client configuration file, and those IPs might change over time, I have one DNS name and it will work regardless of what the backing nodes are.
It'll work for your clients to access the admin portal, but your SDK will need to resolve to individual nodes. If it resolves to the load balancer, you get into this thing of sticky sessions and a whole bunch of stuff under there.
It actually, believe it or not, it does work because what happens is it only connects through 8091 initially to Bootstrap. After that, it gets back the IPs of all the nodes and the SDK connects directly to the nodes.
Ah, got it. Okay. No, I mean, yeah, that's another viable solution.
Okay.
Oh yeah, what's up?
What's the strategy for upgrades? Do you replace nodes or do you replace upgrades?
What's the question?
It's a good one. What's the strategy for upgrades? Do you do in place or do you replace the nodes? It depends, is what I've seen. Small upgrades like 4.6.3 to 4.6.4 in place could make sense. Big upgrades, it's probably nice to be on a clean OS. Regardless, and this is sort of a religious debate, having a clean OS can be nice. So something that hasn't been upgraded from 5 different versions of Amazon Linux, but is on the latest build cleanly, is probably going to have less strange, unexpected behavior. Yeah. Short answer, I guess, if you can, go with a clean one, would be my suggestion.
Yeah.
Uh-oh. Hey, Ben. I've run in, when I've played with AWS, I've run into a problem where if a node goes down and then it comes back up and it's got a different IP address, it won't recognize its data locally. Couchbase server will throw up its arms like, I don't know that data. And I've heard support is kind of recommended using DNS names to get around that because they're more stable. Does this kind of take, have you run into that problem? Does it take any of that into account?
That is a work item. Yeah, we've been thinking about that. There are various ways around it. As you mentioned, you could build your own DNS with Amazon's DNS or something like that. Using the EC2 assigned public DNS names, while those are DNS names, they're still transitory. If you look at the actual DNS name, it just has the IP address in it and then a bunch of Amazon blah, blah, blah. So binding to that doesn't actually solve the problem. You really need to build your own DNS layer on top. Then you end up having to simulate the split horizon DNS, and it just becomes more complicated, which is why we've been looking at other approaches for how to have the node recover with a new name, because that seems like a much more elegant approach if we can make it go.
And then if the rally point goes down, can new nodes come back up?
Oh yeah, totally. So rally point goes down. I mentioned there's nothing special about the rally point. So let's say the rally failed in some catastrophic hardware failure, the CPU melted, and that's gone. And you go into the auto-scaling group, you had 5 nodes, you try to scale it up to 10 nodes. What the scripts will do is they'll check the auto-scaling group, they'll see if a node exists called server rally. If it exists, they'll rally off it. If it doesn't exist, they'll pick a new one, call it rally, and rally off it.
Oh, very cool. Okay. And then one last question. You said within a region, put Couchbase nodes into different AZs. Is there any like extra network latency in between the AZs, or is it pretty fast in between those?
That's a good question. Yeah, so AZs they're supposed to be distinct data centers. but within a single geography. So think like buildings within eyesight of each other. There is network latency. You're going through a whole bunch of network layers. That said, it's really good. It's like count them on one hand kind of milliseconds you're talking about. Couchbase doesn't really seem to need it, but some applications are very, very latency sensitive. The way Amazon has to deal with that is a concept called a placement group. And with that, you can guarantee that servers are right next to each other, like physically next to each other in the data center. What that means, of course, is they're all going to be within the same AZ. So you get performance, you get better latency, but it's back to that cap thing.
Well, as you can hear the pounding next door, the attendees have beaten up the presenter for going so long. So we'll cut it off there, but thank you, Ben and David, for your presentation, and thank you everyone for sticking around so late. Enjoy the reception tonight.
Yeah. Thanks, guys.